start with class 10 coordinate geometry with exercise 7.1. We have already learned the distance formula and its derivation. So we all know that if P x1 y1 and Q x2 y2, if they are 2 points in the Cartesian plane, then distance PQ is nothing but square root of x1 minus x2 the whole square plus y1 minus y2 the whole square. This can also be written as x2 minus x1 the whole square plus y2 minus y1 the whole square. So in short, we can say to find the distance between 2 points, so here PQ can be written as it is the square of the whole square of the difference of abscissa, or we can say the x coordinate plus the difference of ordinate, So here when we write, take any 2 points, that is x1, y1, x2, y2. So we just have to take the difference of x coordinate the whole square plus the difference of y coordinate. So x1 minus x2 the whole square plus y1 minus y2 the whole square. Let's start solving exercise 7.1. First sum. Find the distance between the following pairs of points, that is minus 5, 7, minus 1, 3. So to find the distance between them, let's assign name. For example, here the solution will write, let's take point A. You can take any capital letter, let A minus 5, 7 and B minus 1, 3. Now our aim is to find out the distance between AB. Minus 5 is x1, 7 is y1, x2 is minus 1 and y2 is 3. As you know that it is customary that the first number what we write, it is called as x coordinate and the second one is y coordinate. So if you want, we can just write here x1 is minus 5, y1 is 7. This is not a compulsory step, but just to be like if you get confused, and you can very well write this step. So x1 is minus 5, y1 is 7, x2 is minus 1, y2 is 3. Therefore, by distance formula, we can find out the distance AB. So distance AB, we write the formula. So we can write either x1, we can start, you can select x1 minus y1 or x2 minus x1, any formula I can write. So x1 minus x2 the whole square plus y1 minus y2 the whole square. So here we substitute the square root here, x1 minus x2, so minus 5, this minus, and here already minus is there, so this minus, the formula minus, this coordinate minus, minus will become plus the whole square. y1 is 7, so 7, y2 is 3, so here the formula minus 7 minus 3 the whole square. So here we get minus 5 plus 1, so minus 5 plus 1 is minus 4 the whole square. Here also 7 minus 3 is 4 the whole square. So thus we get here minus 4 square of any negative number is always positive. So we get 16. Here also we get 16. So 2 times we have plus 16. This can be directly written as 2 into 16. Instead of writing root 32 and splitting. So whenever you see that the number is repeating, you know that it is same as 2 into that. That is same as 2 root of 4. That is square root of 16 is nothing but 4. Sorry, I have written root will not come. So here this is nothing but 2. Square root of 2 will come inside, and 16 is nothing but square root of 16 is 4. So the answer is 4 root 2 units. So I hope you have understood that in any 2 points coordinates are given, you just have to do the difference of the abscissa, the whole square plus the square of the difference between the ordinate. Okay, so either you do x1 minus y1 plus the whole square plus x1 minus x2 the whole square plus y1 minus y2 the whole square, this formula, or you can take x2 minus x1 the whole square plus y2 minus y1 the whole square. Both the formula will give the same result, as square of any negative number will ultimately be positive. Let's move to the next sum. The next sum says determine if the points 1, 5, 2, 3 and minus 2, minus 11 are collinear. So here you have to prove that whether the points are collinear or not. So first we will assign them the letters. We will assign them A, B, C, D. So that easy. So solution, let A equal to, so I have assigned let A is 1, 5 B will assume the coordinate as 2, 3, and C we will assume as -2, -11. Now, what do you mean by the word collinearity? Now, when we know that if I want to find whether 3 points are collinear, so we all know the definition that points to be collinear, 2 or more points are said to be collinear if they lie on the same line. So if they lie on the same line, how do we find? Let's take a simple example. Suppose let's take some other PQR. If I say this distance PQ is 2 units and I found that QR is 3 units, QR is 3. So if I find that PQ is 2 units, QR is 3 units, and I know that PR I have already found it as 5 units. So from this we understand that 2 plus 3 I am getting the 2 smaller distance. If I get the bigger length, 2 smaller length, I'm getting the sum of the 2 smaller length, and if I'm getting the bigger length, that means the points PQR are collinear. So if this is given, if this data is given that PQ is 2 units, QR is 3 units, and PR, so we find that 2 plus 3 is 5. That means they lie in the same line. Similarly, to solve this, to find collinearity, we will find 3 distance. We'll find distance AB, we'll find distance AC, we'll find distance BC. We will try and add 2 smaller length and see whether we get the third length. If we are getting same, then we'll say collinear. Let's start solving. So by distance formula, let's find first distance AB. So here we'll write distance AB will find. So AB, when we have to find, again we write the formula for the first time. So I will assume here x1 minus x2 the whole square plus y1 minus y2 the whole square. So when you substitute here x1, so you all know this is x1, y1, x2, y2. So 1 minus 2 the whole square, difference of abscissa the whole square, and difference of ordinates, that is 5 minus 3 the whole square. So when we do this, 1 minus 2 will nothing but minus 1 the whole square. 5 minus 3 is nothing but 2 square. So here we have minus 1 the whole square is 1 square, that is 1, and here 4. So we have root 5 units. So AB is root 5 units. Then we find out the distance BC. Let's find out BC and then AC. Now I'm not writing the formula once it is written. So this is x1, y1, x2, y2. So 2, difference of abscissa. Already here minus sign is there. The formula minus and this will become plus the whole square. Again here 3 minus of minus will become plus, students, and 3 plus 11 the whole square. So here we have 2 plus 2 square, that is 4 square. Here we have 14 square, correct? So here we will get 4 square is nothing but 16. 14 square is 196. So when you add 6 plus 6 is 12, 10, 11, here 212. So let's see, can we split this term? So when I do the prime factorization of 212, so 2 1s are 0s are 6 are 12. 2 5s are 10, 2 3s are 6. So here we find 53 is a prime number. Here we can just put as 2 root 53 units. Next, here when we do the next one, we'll find out what is AC. So when I do AC, here the A we have taken is, let's take the coordinates down so that it becomes easy, or we'll write AC here. We'll find AC here so that we can see the coordinates also. So here we'll find our distance AC. AC is nothing but this. I'll just erase so that we get the space. Okay. So distance AC equals to 1 minus. So 1 difference of abscissa 1. This minus of minus 2 will become plus 2 the whole square. Plus here we have 5 minus of minus will become plus 11 the whole square. So here we have 1 plus 2 the whole square is 3 square. Plus here we have 16 ka square. Here we have 9 plus 16 ka square is, that 256. So here we have 9 plus 6 is 15. So 6 to 65 we are getting. So again the question, can we split it? So when we try to factorize it, it goes by 5 table. 5 5s are 25. And again here we have 5 3s are 15. We always try to write in the simplified form. So here we cannot do anything, rather just write 5 into 53. So when I want to compare, how do we understand which is smallest, because it is another root side? So you know that this is all square root. You cannot have cube root of this. So under the root you check 5 is there, 212 is there, and here 265. So 265 is a bigger thing. It is just applicable like if I say 5 is greater than 4, 4 is greater than 3. So if I put a square root, the same rules apply. The square root of 5 is greater than square root of 4, greater than square root of 3. Correct? So here we find that AB plus BC. When I'm adding, I'm not getting equal to AC. So here, if the sum of the smaller length, two smaller length, if you're getting the third length, then we say collinear. So here AB plus BC is not equal to AC. Therefore, you can say, therefore, points A, B, C are not collinear. A, B, C are not collinear. I hope you understood that whenever you have to check for collinearity, you have to check if the sum of two smaller lengths equal to the third side, then we say that the points are collinear. Now moving to the next sum here. Check whether 5 minus 2, 6, 4, 7, minus 2 are the vertices of an isosceles triangle. We all know the definition of an isosceles triangle, that for the triangle to be an isosceles, two sides of the triangle to be equal. So it is as simple. We will find out all the three distances and check whether the two sides you are getting the same length. So here again to start with, we will write let A 5, minus 2, B 6, 4, and C we are taking 7, minus 2. So we'll find AB, we'll find BC and AC and check whether two lengths are equal. If the two lengths are equal, then we will say that the triangle is an isosceles triangle. So by distance formula, we find out AB, BC and AC. So let's find what is AB. So AB when you find out here, so 5 minus 6 the whole square here, and minus 2 minus 4 the whole square. So difference of abscissa the whole square, square of difference of abscissa plus square of difference of ordinate. So here we get 5 minus 6 is minus 1 the whole square, and we get here minus 6 the whole square. So here we have 1 plus minus 6 the whole square is 36. So we are getting root of 37, right? Let's find out what is BC. So find BC here. We find BC, that is square root of, again square of difference of abscissa plus square of difference of ordinate. So here we have 6 minus 7 the whole square plus 4. Here we have minus, so minus of minus will become plus 2 the whole square. So here we have 6 minus 7 is nothing but minus 1 the whole square. So here we have minus 1 the whole square plus 4 plus 2 is 6 square. So here we are getting 1 square plus 36. So again root 37 units we are getting. Let's find the final AC. Should we leave this without finding the third as we got two distance? No. If suppose AC is also root 37 units, then we can claim that it's an equilateral triangle. So third distance is mandatory that you have to find. So again see 5 minus 2 and 7 and minus 2. So we have 5 minus 7 the whole square plus here we have the difference of ordinate, that is minus 2. Here minus 2, here minus is there. Minus of minus will become plus 2 the whole square. So here 5 minus 7 will give you minus 2 the whole square plus 0 square. So here we have minus 2 the whole square is plus 4. So here we find that AB and AC are equal. AB equals to AC and which is not equal to AC. Therefore, ABC points ABC, we can say, okay, I'll just write here, points ABC are the vertices of an isosceles triangle. I hope you have understood. Exercise 6.1 is very simple because it's just based on the distance formula. You just have to understand distance formula and you have to solve. If you have understood, you can check for 3 points isosceles and so on. You can use it. So in the next video, we'll see the next part. Thank you.